Hey guys, Mr. T here. This is another video. Apologies in advance. The windows are open. It's really hot here, so there might be some really loud cars driving past. But we should be able to get through it. So this video is about congruence and congruent triangles. So in maths, if two things have the same shape, the exact same shape and size, maybe they're just in different positions, but they're in the same shape and size, they're said to be congruent. So basically, congruent is the mathematical word for exactly the same. So if you're discussing two figures specifically, so two shapes drawn on a page, then if they have all the same length sides, all the same sized angles, and all the sides and angles that are the same are in corresponding locations, the figures must be congruent. So we need to move on to the idea of congruent triangles. A triangle is a polygon with three sides and three angles. Hopefully that's revision for you. Now, a special property of triangles, because they have these limited three sides and three angles, is that only one specific triangle can ever be drawn if you know three sides, or two sides and the angle between them, which is called the included angle, are given, if two angles and a side are given, or if a triangle has a right angle and you know the hypotenuse and the other side, it's only ever going to be one kind of triangle that you could draw, given that information. So because of these four unique situations, it's actually possible to decide if two triangles are congruent without a complete set of information or a complete set of angles and sides. You only need one of these four situations to prove that the triangles are congruent. So to illustrate that a bit better, more formally, two triangles are congruent if all the corresponding sides are equal in length. So here, these two red triangles here, one side is one dash, longest side is two dashes, and then the sort of medium length side is three dashes. Even though this isn't in the same orientation, it's just been flipped. You've got the shortest side is one dash, longest side is two, medium length is three, so they're in all their corresponding locations. We know that they're the same sizes, so this must be congruent. And that rule is known as the Sss Rule, or side, side, side. The other situation that proves triangles are congruent is knowing two sides and the included angle are equal. So this is the situation here. You know the angle between the two sides that you know is equal in both, therefore the triangles are congruent. This is known as the SAS, or the side angle side rule. The third situation is that two angles and a corresponding side are equal. So it's important to spot that the corresponding side is equal. This is known as the AAS rule, or the angle side. And you can see here the two triangles, even though they're flipped, the side that we know is directly adjacent to the B angle. And then A is like on the adjacent angle, so next to the B corner here. So these are all in corresponding, this side, is in a corresponding location, even though this triangle's flipped. We know the two angles are equal, and one of the sides is equal. It's in a corresponding location, so that is congruent as well. So that's the AAS rule. And the last rule is when they have the triangles have a right angle and you know the hypotenuse and one other side are equal. This is known as the Rhs rule, or the right angle, hypotenuse, and side rule. So if you've got a right angle triangle, well, two right angle triangles, and you know the hypotenuses, I think that's the plural of that, but we don't know. If the hypotenuses are equal in both, and then the other side in the corresponding location are the same length, so here we've got the short side is indicated by one dash, and the short side here is indicated by the one dash, they are congruent. So that is a coverage of the four rules. To save you time in writing right angle, hypotenuse, side, you can just write the rules as RHS. Because if you are asked to prove congruence, you must explain why by stating which rule indicates the congruence. So to show you what I mean by that, we've got a couple of examples. So let's say we were given this. Are triangles ABC and KLM congruent? So ABC is a right angle triangle. We know it's right angled, and then the side opposite the right angle is 5, the side adjacent to the right angle is 4. KLM, we've got the side opposite the right angle is 5, the side adjacent to it is 4. We know that the hypotenuses are the same. We know that there's a right angle, and we know the other corresponding side is the same, so we can say that they're congruent. Triangle ABC is congruent to, so this is a symbol for congruence. It's got a little swirly line and then an equal sign underneath. Triangle KLM, and you need to explain why. Because, so that's the symbol for because of RHS. It's RHS because we know they're right angled, we know the hypotenuse, and we know the last remaining, one of the corresponding sides in both. Now, so that's just an example of how you show that they're congruent, just applying the rules. You need to use this symbology, these symbols, or this way of writing it formally for full marks, okay? So the second example here, are triangles ABC and XYZ congruent? So we've got, these aren't right angled, we've got angle A, angle B there, and adjacent to angle B is the side that's 1 dash. Now let's look at the other triangle. We do have an A and we do have a B here, but the side is adjacent to A, it's not adjacent to B, so it's not corresponding. The side that we know is opposite of A. We don't know what the side is that's opposite A here. In fact, the side that we know is opposite to B. They're not corresponding. So, angles A are equal. There was a loud car that I was talking about. Angle B are equal, but known side is not corresponding. Therefore, not congruent. Okay, I forgot to write that, therefore, due to RHS, that these triangles were congruent. Okay, so that is an application of trying to apply the rules. So it looked like we were going to angle side, but the side is not in a corresponding location, so it's not congruent. Whereas here, it was right angled, we knew the hypotenuse, we knew one of the corresponding sides in both, therefore congruent, and that's how you write the rules that explain why they're congruent. So hopefully that helps you out with congruence and congruent triangles, and I'll see you in the next video.